Good question. Okay, so where I approach these problems from. First thing I do on any kind of these word problems is how many variables am I going to need? And I determine that based on figuring out how many things am I being asked to find. I saw some fingers going up in the back. How many variables am I going to need? 2. That must mean that there's 2 things that I'm being asked to find. What are the 2 things that I'm being asked to find?
How many grams of each solution we need to prepare the bacteria?
Yes, this, I'm not going to say the whole word, the bacteria side. It's a disinfectant. That word is much more familiar to me. They're trying to prepare a disinfectant that specifically will kill bacteria here. So we need to figure out how many grams of each. What is it that I have to work with? When they say, like, how many grams of each, I imagine 2 bottles in front of me that I'm going to be mixing, right? What are those 2 bottles? Yeah, I have water, and then I have this ethanol solution that is already a 95% ethanol solution. So most of what's in that bottle is ethyl alcohol. There's just a little bit of water added to this other bottle. And then I have a bottle of pure water, correct? Mm-hmm. Okay. So I'm going to call my 2 variables x and y. Are you guys okay with that? Okay. So I'm going to let x, since I'm being asked to find number of grams, that's what my variables are going to represent. Number of grams of, one of them is this 95% ethyl alcohol solution. And then my other variable is going to be y, and that's number of grams of water. So far, so good? All right, that's the first part of this battle. It's just what are my variables and what do they mean? Now I need to figure out my equations. How many equations do I need? 2 again. If I only have 1 variable, I usually only need 1 equation. If I'm after 2 solutions, I need 2 equations. So what should my equations be about? What do I know about what I want to end up with? 400 grams. So that would be a total amount, right? What else do I know about this? 75%. That's not a total amount, is it? That's a total concentration. So this is telling me this 75% alcohol by weight. If I had a way of removing all the water from it, 75% of the volume or the mass is going to be alcohol. So I'm going to write one of my equations about the amount, since I have a total for that, and I'm going to write the other equation about a concentration, since I know what I want to end up with there. All right, so we have amount and concentration. Let's do the amount one first. I want a total of how much? 400. That's my total. It doesn't matter whether you begin or end, but I have 400 on a side by itself, right? How do we get to a total of 400 grams? X plus y. Grams of this ethyl alcohol solution together with grams of water gives me a total of 400 grams. So far, so good?
Wait, how do we know that x plus y equals 400?
Well, I know that my total amount that I want is 400 grams. And I know that x means number of grams of this thing, and this means number of grams of the other thing. So when I look at this equation, it's grams equals grams plus grams. My whole equation, all the values there, including the variables, I've got consistent units. Grams equals grams plus grams. So far, so good? Okay. Now we're going to talk about the concentration. What do I want the concentration of my final product to be? 75%. 75% of what should be made up of this ethyl alcohol?
400.
Of the 400. So I'm going to do 0.75 times 400. This is how much alcohol is in the final product. Good on that? I'm calling it concentration because that's not a total amount. That's the total amount of one component of this. So I have 0.75 times 400 is equal to, I've got these two variables. What is the concentration of X? 95%. So I'm going to do 0.95 multiplied by X. This would be how much alcohol is in my 95% solution. So far, so good? All right, I'm writing a lot up here because I'm really trying to make my thinking clear. This is a process called metacognition where we're thinking and talking about thinking. So I know how much alcohol I want in my final product. It's going to be 75% of the total volume. I know how much alcohol is in this. If I knew how many grams of this I was adding, I would know exactly how many grams of alcohol would be going in. What is the concentration of alcohol in water? 0. So I've got plus 0 y. That's not just the 0 there, it's the 0 y. Yep.
Why did you put the X after 0.05?
Because I'm going to multiply them together. I'll explain. Let me get this written down real quick, and then I'll absolutely dig into that. All right. So the analogy that I was using, or the way I was thinking about it on Friday, doesn't fully hold up here when I'm talking about alcohol, but any kind of mixture problem, I can use the same thinking. On Thursday and Friday, when we had problem number 8, that was the mixture problem where they were talking about a glucose solution, same idea, because I've got a solution, a mixture. If I take a glucose solution and I put it on the stove and I heat it up, all the water is going to evaporate off, right? And I'll only be left with the glucose, the sugar, in my pan. So I'm going to think about this the same way. If I had a way of making just the water part evaporate, this right here, 0.95 times X, this represents how much alcohol I would actually have. Because 95% of it is alcohol, times however many grams I put in, gives me the total volume of alcohol. Does that make sense? Okay, awesome. Are you guys okay with the meanings of my two equations? Okay. Now that I've got two equations written, I can start to simplify and solve. I'm going to start with this hot mess down here because, well, it looks like a mess. It cleans up pretty fast. Is there anything here that I can simplify? Is there anything that I can simplify from that bottom equation? 0.75 times 400 would be how much? 300. So I have 300 equals 0.95x. Can I simplify the 0y at all? What would that simplify to give me?
0 times anything is just 0.
Yeah, 0 times anything is just 0. And if I'm adding 0 on the end, do I have to write it down? So that pretty much just drops out. Since it has no alcohol in it, I just get a 0 from that. All the alcohol has to be coming from this 95% solution, right? What would I do from here to figure that out? Divide. So we're going to divide both sides by 0.95. If you were given a calculator to use, that would be a piece of cake. We're expected to do this class, at least on tests and quizzes, without calculators, right? So how can I actually divide that without using a calculator? We're going to reach back in our memories. If I want to move this decimal point over 2 places so that I don't have a decimal, add 2 zeros up to the top. Now I'm working with just whole numbers. So now I'm going to write down my long division over here. We're dividing this by 95. Does 95 go into 30? Does it go into 300? How many times will 95 go into 300? 3 times. So I've got a 3 up on top. Let's see, that's going to be 15, 27, 28, right? Subtract that off. How many am I left with? 15. And then I'm going to bring down a 0. How many times does 95 go into 150?
Once.
Just once. So I have 95. I'm going to subtract that. What does that leave me with?
55.
55. I'm going to bring down my final 0 here. How many times does 95 go into 550? Five times. So I'm going to put a 5 up here. Let's see, that would be 25, 45, 46, 47. Subtract it off here. So I have 5 and 7. 75 left over, right? I can keep going to get a decimal, or I can just write it as a fraction right here. It's 315 and how much do I have left over? 75 out of 95. Can I reduce that fraction? What will go into both of them? 5. So for x, which is the grams of the 95% solution, it's 315, and then I need my fraction here. What is 75 divided by 5? 15 over 19. I need this many grams of the alcohol. Altogether, I want how much? 400. So if I do 400 minus this 315 and 15 over 19, that will give me how many grams of water I need. Let's see. That's almost 316. What's 400 minus 316? 84. And now I just have to figure out what my fraction should be. What would I need to add to the numerator to make this 1? 4. This is the grams of water needed. than the fact that we had to divide by a decimal and we had to get into some weird fractions, give me like thumbs up, middle, or down, coming up with what the variables should be. All right. Knowing how many variables we should have. Knowing how many equations we should have. Writing either of the equations. Writing both of the equations. Okay, cool. I have a good idea of where we are and where we need to go. Thank you. We're going to keep practicing with story problems. We're going to do one each day. We'll get better at them. For the rest of our time today, though, we're going to scoot on into 2-3, which is quadratic equations. We are going to look at a special case for quadratic equations. You guys are used to always hearing that when we're solving quadratics, it has to be equal to 0. None of these are equal to 0. In the first two, though, I only have x squared and then equals a number, right? I can use order of operations here. I don't have to use quadratic formula or factoring to solve these. I can use what I know about order of operations. What is order of operations? Yes. Parentheses, exponents, multiplication and division, addition and subtraction. We're solving, so I'm moving my way backwards through the order of operations. There's only one operation to undo here, though. What is that? Exponent. How do I undo an exponent of 2? Square root. What is the square root of x squared? X. Be really careful here. What's the square root of 49? Plus or minus 7. If the question was just, what is the square root of 49? We would usually go with just the primary square root, the positive one. But the question we're trying to answer here is, what number squared gives me 49? That's both the positive 7 and the negative 7. So I have two solutions here. I'm going to go look at B. B is set up almost the exact same way. So if I'm going to continue to apply this kind of special case, how should I go about trying to solve B? Same thing. I'm going to take a square root of both sides. Which means I'm going to get how many answers? 2. One positive, one negative, right? So I have x on this side. I have plus or minus the square root of 45. This is not fully simplified yet. I need to simplify this. There are several different ways that you can go about simplifying radicals. I know in some Algebra 1 classes they teach the birthday cake. Did anybody learn the birthday cake where you go all the way up to a candle? Mm-hmm. Some teachers did factor trees, where you start off with a number and you end up with all these branches down below. My method is kind of a combination of those two. You could also go looking for what perfect squares divide this, if you know your perfect squares really quickly. I usually look at this number underneath the square root. The part that I like about the birthday cake is that you're pulling out your prime numbers. I don't like that on the birthday cake, if I think of a composite number first, like 45, I'm like, ooh, 9 goes into that. 9's not prime, though, is it? What goes into 9? 3. Instead of trying to just rack my brain for this, I write down what I see first. 45 is 9 times 5, right? Are either one of those perfect squares?
Yes.
Then I can just kind of stop and say, okay, what's the square root of 9? 3. Is 5 a perfect square?
No.
Can I break it down anymore?
No.
Then it would be 3 square root of 5. If you need to make it more explicit for yourself, I can always break down that 9 and say, well, 9 is 3 times 3, and then times 5. 3 times 3 times 5 gives me 45. And if I can see a pair of primes, I know they would multiply together to give me a perfect square. So I can still see that square root of 9 right there to get the 3 on the outside and the 5 on the inside. So this would be x is equal to plus or minus 3 square root of 5. You guys okay with that? All right. Let's look at part C. You could do this a couple different ways, but I want to continue using this pattern that we've worked on here. I had somebody earlier today that got the same answer as me, but what they did is they squared their binomial, they set it equal to 0, and they factored it. Can you solve it that way? Yes, you can. I want to work on using this special case scenario to solve this one because it's going to be really helpful tomorrow for some of our problems. So I'm going to apply exactly what we've done before. We're going to do a square root of both sides. So on the left, I have x minus 4. What do I have on the right?
Plus or minus 9.
Plus or minus 9. I want to get the x all by itself, so what would I do now?
Add 4.
Add 4 to both sides. So I'm going to get x equals 4 plus or minus 9. Is that fully simplified? No. How many answers do I get from it? 2. Tell me how to get one of them. 4 plus 9, which would give me 13. How do I get my other answer? Yep, x equals 4 minus 9, which is what?
Negative 5.
-5. If it's got a radical in between, or if we have a radical still, even after we fully simplify it, then your final answer is going to have a radical in it. Without a calculator, I cannot ask you guys to give me decimal approximations. If it doesn't have a radical anymore, you've got to fully simplify it by combining all your like terms. So far, so good? All right. Let's go back and review some quadratic formula stuff. I'm going to hold here for just a minute because I see there's still some people writing stuff down. As soon as I know I've got everybody on the same page, I'll go to the next screen. If you remember quadratic formula, you should write it down on your page. I had a couple people singing the quadratic formula song earlier. Everybody else learned a better version of that than me. When I was in school and they taught us quadratic formula, they did it to the school fight song. So not only will I never forget quadratic formula, but I will never forget our school fight song either, which, yay. All right, let me pop it up on our screen here. What is quadratic formula? Absolutely correct. X is equal to negative b, or you might also think of that as the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. That part that's underneath the radical, the b squared minus 4ac part, that is called your discriminant. And when I'm doing quadratic formula, I always find that first. Because if I just substitute all the pieces into quadratic formula, I got so much going on there that it gets a little visually overwhelming for me. And I also tend to find that I make silly mistakes, especially with my signs, when I do it all at once. So I find this part first, and then I make my substitution. We are using quadratic formula here, and so I need to make sure that my equation is, what's super important? Equal to 0. I need my equation to be equal to 0. On the first one, I got that. Then I want to go through and find my a, b, and c values. What is my a value? 2. My pen got a little messy there. What is my b value? Negative 3. Good job grabbing the sign with that one. And c? Negative 4. I take this and I sub it into the formula for the discriminant. So we're going to square the b minus 4ac. So what are we squaring? Negative 3. Anytime I square a number, whether it's a positive or a negative, what type of number do I get back? Positive. Negative 3 squared is 9. What do I put in those other two parentheses? 2 and negative 4. Got to make sure that I do this part correctly. I have negative 4 times 2, which gives me negative 8. And then I take the negative 8 and multiply it by negative 4. Negative times a negative gives me a positive. Positive what? 32. So I have 9 plus 32, which gives me 41. This is what goes underneath the square root. So now I'm going to substitute everything in. X equals, I got my big fraction bar. I always do this the same way every time so that I don't make any silly mistakes. I always have the negative and then parentheses because in my formula there's a negative and then b. What are we putting in for b? Negative 3. I'm really bad about missing signs, which is why I do this, so that I see really clearly what is going to happen right there. What jumps out to you about this? Yeah, I'm going to end up with a positive 3 right there because I have a negative and a negative. What am I putting underneath the radical? 41. And down on the bottom? 2, so that it's going to end up being a 4, yes. I need to know if that radical simplifies at all, because that would be the last thing I need to do here. So the square root of 41, will 2 go into 41?
No.
Will 3 go into 41?
No.
4?
No.
5? 6? Can you think of anything that goes into 41?
No.
If it doesn't simplify, then I leave it alone. 41 is prime, by the way. So we're going to leave it as just the square root of 41. Without a calculator, that's as far as I could ask you to take it. How many solutions did we just find? 2 solutions. When your discriminant, this value right here, comes out to be a positive number, you're going to get two real solutions. Does anybody remember if this right here comes out to be a negative, what kind of solutions we have?
You said the number like under the radical?
Yeah, if the number under the radical comes out to be a negative number. Imaginary. We end up with two imaginary roots. We're not doing those right this minute.
Oh, yeah.
But you're going to have the I under there, because remember, we can't take the square root of a negative. And that's where the I comes in. What would happen if that came out to be 0? If I get a 0 under the square root?
Well, wouldn't square root of 0 just be 0?
Square root of 0 is 0.
Would that still be two solutions?
Good question. Is it two solutions still? One solution. Because if I do something plus 0, like 5 plus 0, it's just 5, right?
Yeah.
What's 5 minus 0? Still just 5. So when I get a 0 here, this basically doesn't matter anymore. And I just have negative b divided by 2a. Where should I start on b?
Ms. Bull,
Yes, I'm sorry.
the last problem.
Mhm.
What if 30 was a 4? Could you simplify that, or no, because of the plus? and
No,
minus?
you are correct. We can absolutely simplify it.
Oh, okay.
Yes. And we should. We'll look at things. Yep, we'll look at one yet that simplifies there. All right. Where do I start on b? Yes, subtract 2 from both sides, set it equal to 0. 6x squared minus x minus 2 equals 0. Now I want my a, my b, and my c. What is a? 6, b, negative 1, and c, negative 2. From here, I sub into the discriminant part. So what are we squaring? Negative 1. And what do I put in the other two parentheses? 6 and negative 2. So I have negative 1 squared, which is just 1. And then minus, let's see, that's going to be negative 24 times negative 2. Yeah. Positive or negative 48? Positive. Negative times a negative gives me a positive. So what is my discriminant?
It's perfect.
49. It's a perfect square. What's that going to mean for when I'm simplifying this?
You can simplify it, right?
Yes, I can fully simplify my radical there. I'm going to put negative 1 into my first set of parentheses there. 49 goes under the radical. And what goes down in the bottom?
6.
6. So help me clean it up a little.
Square root of 9. All right, let's start with the negative 1. It should be positive 1.
Going to have a positive 1, plus or minus 7, all over 12. Done?
No.
No.
I can keep simplifying. 1 plus 7,
8.
so I have 8 over 12. Can I reduce that at all? What do I get? 2/3. So there's one solution. And then for the other one, 1 minus 7, negative 6 over 12 reduces to negative 1/2. Last one. What are my A, B, and C? Yep, 3/2, 3 over 2. B is?
Negative
4,
4.
and C?
Negative 1.
-1. Let's find our discriminant. right, so we're going to square the negative 4 and get, what? 16. And then 4 times 3/2 is 6. So negative 4 times 3/2, I have negative 6, but then I take it times negative 1. So I get a plus 6 right here. What's that going to give me? 22. Is this one going to come out pretty like the last one?
No.
Nope. 22 is not a perfect square. So up in my numerator, I have negative and then negative 4. So that's going to simplify to give me a positive 4 there. Can I simplify the square root of 22?
No,
Why not?
because
Prime.
when you break it down, you get 2 and 11, and they're both prime numbers, but nothing comes out of the radical.
Absolutely 100% correct. All right, so I have x equals 4 plus or minus the square root of 22 all over what? 3. Can I simplify that any more than that? Nope.
Do you want us to write how many solutions?
No, but if I ask you for 2 solutions, I expect you to write it down, one with the plus and one with the minus.
Sure.
As far as reducing the answer goes, if you can simplify your radical, and those 3 numbers, these 2 and whatever's outside your radical, if they're all able to be divided by something, you would divide those 3 numbers. Kind of like pulling out a GCF. Never the number that's under the radical. It doesn't matter if it's divisible by the same thing or not. Once you've simplified your radical, you don't touch what's under there anymore. All right?